A triumphant touchdown. Perseverance arrives on Mars. On February 18, 2021, the world watched as NASA's Perseverance rover completed its descent to Mars. The landing in Jezero crater marked the start of a mission to uncover Mars's ancient secrets. Equipped with sophisticated instruments, Perseverance will search for signs of past life. Its mission also paves the way for future human exploration. Jezero crater, once a lake, could hold vital clues if life ever existed on Mars. Perseverance will collect and store samples for future return to Earth. The MOXIE instrument will attempt to produce oxygen from Mars's atmosphere. Perseverance's success is a testament to human ingenuity and our desire to explore the cosmos. Guardians of the Red Planet. Protecting Mars from Earth. The search for life beyond Earth is a delicate endeavor. As we explore other planets, we must take extreme care not to contaminate them with earthly life. This principle of planetary protection is paramount in all of NASA's missions to Mars, especially with Perseverance. The rover underwent rigorous sterilization procedures before launch to minimize the risk of carrying Earth-based microbes to Mars. Every component of Perseverance, from its wheels to its scientific instruments, was meticulously cleaned and sterilized. Engineers used heat, alcohol wipes, and even ultraviolet radiation to eliminate any lingering microbes. The assembly of the rover took place in a specialized cleanroom facility where the air is filtered to remove even the smallest particles. Workers in the cleanroom wore full-body suits, gloves, and masks to prevent contamination. The search for life on Mars depends on our ability to distinguish between indigenous Martian life and any earthly hitchhikers. If we were to inadvertently contaminate Mars with earthly microbes, it could confound our ability to interpret future findings. The strict planetary protection protocols surrounding Perseverance demonstrate our commitment to responsible exploration. By taking these precautions, we aim to ensure that any discoveries made on Mars are truly representative of the Red Planet's own history and not the result of contamination from our own world. The search for life beyond Earth is a quest for knowledge, and that quest must be conducted with the utmost care and respect for the environments we explore. Rewriting Martian history. Unexpected discoveries abound. Since its arrival, Perseverance has been diligently exploring Jezero crater, and the data it has sent back is already challenging our assumptions about Mars. The rover's instruments have detected a surprising diversity of rock types, suggesting a more dynamic and complex geological history than previously thought. These findings are painting a new picture of early Mars. One of the most intriguing discoveries is the presence of olivine-rich rocks on the crater floor. Olivine is a mineral that typically forms deep within a planet's mantle and is not commonly found on the surface. Its presence in Jezero crater suggests that these rocks were brought up from the depths by powerful geological processes, possibly volcanic eruptions or large impacts. Furthermore, the rover's radar has detected signs of layered rock formations beneath the surface, hinting at a history shaped by periods of deposition and erosion, possibly linked to the ancient lake that once filled the crater. These layered formations could preserve a record of Mars's changing climate over billions of years. These early findings from Perseverance underscore the importance of ground-based exploration. While orbiting spacecraft provide valuable global perspectives, rovers like Perseverance allow us to examine the Martian surface up close, revealing details and complexities that would otherwise remain hidden. Each new discovery is a piece of the puzzle, helping us to reconstruct the history of this enigmatic planet. The ingredients of life: organic molecules and Martian water. The search for life beyond Earth often focuses on the identification of organic molecules, the building blocks of life as we know it. While organic molecules are not necessarily evidence of life itself, their presence can indicate environments that may have been habitable in the past. Perseverance has made an exciting discovery in this regard, detecting organic molecules in the rocks of Jezero crater. The rover's Sherlock instrument, which uses ultraviolet light to analyze the composition of Martian materials, detected these organic molecules within the crater floor. The specific types and distribution of these molecules are still being studied, and further analysis will be needed to determine their origin. However, their presence is a tantalizing clue that suggests ancient Mars may have possessed the necessary ingredients for life. Adding to the excitement, Perseverance has confirmed the presence of water molecules bound within the Martian soil. This discovery, while not entirely unexpected, provides further evidence that water, a crucial ingredient for life, was once abundant on the Martian surface. The rover's findings are fueling optimism that Jezero crater, with its ancient lakebed and evidence of organic molecules, could hold the key to unlocking the secrets of life on Mars. A planet transformed, from warm and wet to cold and dry. Today Mars is a frigid desert, its thin atmosphere offering little protection from the harsh radiation of space. But evidence suggests that the red planet was once a very different place, with a thicker atmosphere, flowing water, and a potentially habitable environment. What caused this dramatic transformation? Scientists believe the answer lies in the loss of Mars's magnetic field. Billions of years ago, Mars, like Earth, possessed a global magnetic field generated by its molten core. This magnetic field acted as a shield, protecting the Martian atmosphere from the constant bombardment of charged particles from the sun known as the solar wind. However, over time, Mars's core cooled and solidified, causing its magnetic field to weaken and eventually disappear. Without the protection of a global magnetic field, the Martian atmosphere was left vulnerable to the solar wind. Over millions of years, the solar wind stripped away much of Mars's atmosphere, thinning it to its current wispy state. As the atmosphere thinned, the planet's surface pressure dropped, causing liquid water to evaporate into space or freeze beneath the surface. The once warm and wet Mars transformed into the cold and arid world we see today. Reading the rocks, clues to Mars's ancient past. Perseverance is not just exploring the surface of Mars, it is also digging into the planet's past. The rover's drill is collecting rock cores, offering us a glimpse into Martian history spanning billions of years. Analysis of these cores has revealed intriguing patterns and deposits, providing clues about the planet's ancient environment. One significant finding is the presence of iron and phosphate-rich patterns within some rock layers. These patterns, which resemble stromatolites found on Earth, could be signs of ancient microbial life. Stromatolites are layered structures formed by the growth of microorganisms in shallow water environments. While further analysis is needed to confirm their origin, the presence of these patterns is an exciting development in the search for past life on Mars. In other areas, Perseverance has discovered deposits of calcium sulfate, a mineral that typically forms in the presence of water. These deposits, some of which are extensive and well preserved, suggest that water once flowed through these regions in significant quantities. The composition and distribution of these deposits are providing insights into the chemistry of ancient Martian water and the potential for habitable environments.